Hey IG students, welcome to page 18 of our practice exam paper, which we're doing on Monday. I think it's the 30th, can't remember. Sounds about right. Okay, so we'll read along this question together. We've got car A and B. They're making a race. They're doing a race around a circular track, and the lap length is 7.6 kilometres. Car A takes 2 minutes and 40 seconds to complete each lap, whereas car B takes 2 minutes and 25 seconds to complete each lap of the track, and they're travelling at a constant speed. And we have to calculate the speed of car A. So we'll start off here, A. Speed. Now, what does speed equal? Speed is equal to distance divided by the time taken. Now, we are meant to give our answer in kilometres per hour, which means we want to have our distance in kilometres and obviously our time in hours. So the distance part of this equation is fine, given that they give you the distance of a lap in kilometres. That's okay, but unfortunately our speed is in minutes and seconds. So what I'm going to do is I'm going to convert my my time, which was 2 min 40 seconds, and I'm going to convert that into seconds. Bear with me. So 1 minute is 60 seconds, 2 minutes is 2 lots of that, so that's 120 seconds, plus the 40 seconds. 120 plus 40 is 160. Now I'm going to put 160 seconds, but how do I convert seconds into minutes? I divide by 60. How do I convert seconds into hours? I divide by 60 times 60, since each minute, there are 60 minutes in an hour and there are 60 seconds in each minute. So I'm going to divide it by 160 over 60 times 60, which is 3,600. Now, that gives us in hours. And so if we do this, you can check it on your calculator, you're going to get, I think it is 171 kilometres per hour. Maybe just check that. Okay, now that's all very well. That's not quite a nice question. The next one is a little bit more tricky. In this question, we have two cars. They start at the same position, and we've got to find the time in minutes and seconds when they're at the same point again. Now, you know, since they're going at different speeds, you know, I mean, it's kind of obvious. If this is one car is going faster than the other around the laps, it's going to take, there'll only be certain times when they're at exactly the same point on the track. So we've got to find the next time. They start at the same point. When do they next meet at the same point? Well, one way of doing it is to say car A takes 160 seconds to get round the track, and car B takes 145. And then you could just go like this, 290, goodness, etc., and find when those times match. And that will give you the lap number as well. But boy, that is going to take a long time in this case. So let me teach you something that I used to teach my year 5 and 6 students called prime factorization, or factor trees, and then we're going to use that to find the lowest common multiple. So let's do a factor tree first of all for 160. We could say that it is 2 times 80, and we're going to circle our primes. That's a prime. And then we could say, well, it's 4 times 20. We haven't got a prime there, but this one is 2 times 2, isn't it? So a couple more primes there. And then we've got 20 here, which is 4 times 5. That's a prime. And then 2 times 2. Those are all primes. Okay, now we've finished our factor tree. So we're going to do the same for 145. Okay, so for 145, what have we got here? Well, it's 5 multiplied by 29. And both 5 and 29 are prime, so that is our factor tree, maybe a factor shrub. Okay, now, how do we find the lowest common multiple? Well, you start with your lowest prime numbers. Okay, 2's. We've got 1, 2, 3, 4, 5. Okay, so the lowest common multiple has to have 2 to the power of 5 as a factor. That's got to go into it. Then we've got 5 here and 5 here. They both have 1, 5. So they've also got to have the factor 5 in them. And then finally, 29. Well, this one doesn't have 29, but this does. So 29 must also be a factor of the lowest common multiple. And when we multiply these all out, 2 to the power of 5 times 29, we end up with 4,640 seconds. Because remember, these ones were in seconds, right? 4,640 seconds. Now, that's not what they've asked us for. They have asked us for minutes and seconds. How are we going to turn this into minutes? We are going to divide by 60. So when you divide by 60, what do you get? Well, let's do it. 4,640 divided by 60 is giving me 77 whole minutes. Now, the mistake that some of you might make at this point is go, oh, and 0.333333 seconds. No, that's 0.333333 minutes. So you need to convert that into seconds. Now, if you know what 0.33333 is, it's 1/3. So you could say it's 1/3 of a minute, which is 20 seconds. Now, if you can't do that or you didn't click, you could have gone 77 times 60, because you've got 77 minutes, and that will give you 4,620 seconds, which leaves you with 20 more to make up the total time of 4,640. I hope that makes sense. So that's the answer to the second part of the question. Now the final part is asking you the distance that car A has travelled at this time. Right, so we probably want to think, how many laps has car A done? So car A has a lap time of 160 seconds. When they meet, it's travelled for 4,640 seconds. So how many laps is that? It's going to be 4,640 divided by 160, and that gives me 29 laps. So car A has done 29 laps when they meet. What is the distance that it has travelled? Well, each lap is, according to the question right at the top, 7.6 kilometres. So total distance will be 29 multiplied by 7.6, and I get 220.4 kilometres is my final answer there. So I hope that helps you out. If you're a little bit confused about using factor trees and prime factors to find the lowest common multiple, there are plenty of videos on YouTube that can explain that and give you a couple more examples. If you're still stuck, email me and I'll give you another example. Take care.